Hi my dear friends, welcome back to our YouTube channel. This is ADC Max. The first pair, the formulae under this Fourier transform is complex Fourier transform pair. What is a Fourier transform? It's a mapping between the two sets. The input is f of x, and the Fourier transform, the outcome is f of s. S is the parameter. So the inputs are and the outputs are in two different parameters, two different variables. So this is the huge difference between the existing ordinary transformers and this Fourier transforms. This can be defined for the whole real line system minus infinity to plus infinity. Let us see that definition, the formula. The Fourier transform of f of x is equal to 1 by square root of 2 pi f of x e to the power I s x. What's the I? I is a complex number. This is called the kernel of the Fourier transform. Kernel. This is in terms of the complex number. This is called complex Fourier transform. This is called full range for the minus infinity to plus infinity. For minus infinity to plus infinity. After integrating this with respect to x, the output is decided by this kernel. This is known as the kernel. It's often called as the processor. It's called the kernel. This is in terms of the parameter yes, so the outcome is only yes. Right? So Fourier transform of f of x is equal to integral minus infinity to plus infinity f of x e to the power I s x dx. After integrating with respect to x, the output is f of s. This way. What about the reverse? This is called inversion formula. The inversion formula means the inputs are yes, the outcome is x. So 1 by square root of 2 pi integral s is equal to minus infinity plus infinity. Let us integrate the input variable f of s e to the power minus I s x ds. So now this is called the inverse kernel of the given Fourier transform. How this becomes minus I? Because e power I s x. What is 1 by I? Because when we go for the inverse, 1 by I, always called I power minus 1. What is 1 by I? 1 by I is equal to 1 by I. Multiply and divide by the conjugate. We get it is minus I minus I. 1 into minus I is minus I. The denominator, I into I is I squared. I squared value is minus 1. Minus or minus plus 1. So that's why this comes minus I. This is called the inverse. 1 by I minus I s x. Now this time we are going to integrate with respect to s. So that's why the output is f of x. So this is called the inversion formula. Once the Fourier transform exists, then the inverse is possible. The same way, once the differentiation exists, then only the integration is possible. The same category. So this is the first formula under the complex Fourier transform. When we use the definite integral property, integral minus a to plus a f of x dx is equal to 2 times integral 0 to infinity f of x dx. When we write like this, if the function is even, this can be written as twice the time. Similarly 0 once the function is odd. So under the assumption that under the definite integral property for even functions, this full range can be divided into two half ranges. Similarly, like the Fourier series, full range, half range series. Half range series, there are two types, sine and cosine. Here also, I am going to split up this into the two types. What are they? Before going to that, can we write e to the power I s x I is equal to cos sx plus I sin sx? Is right? Right? And what about under the case of even, what happened this becomes twice the time integral x is equal to 0 to x is equal to infinity. What about 1 by square root of 2 pi? This is there. So after cancellation of 1 root 2, this becomes root 2 by root pi. So under the even category, I am going to split up the whole complex Fourier transform into two types. One is sine transform, another one is cosine transform. So the second one is Fourier sine transform pair. Fourier sine transform pair. Fourier sine transform pair. So Fourier sine, S stands for sine transform of f of x. So what happened the constant now? Yeah, normally the constant is 1 by square root of 2 pi integral minus infinity to plus infinity. Now due to this property, we can rewrite this by minus 1 by square root of 2 pi. 2 y is the time 0 to infinity. After cancellation of 1 root 2, this becomes square root of 2 by pi integral x is equal to 0 to infinity f of x sine transform. So sine sx into dx. So this is the kernel of the Fourier sine transform. So the output is f s of s. S in the suffix indicates the Fourier sine transform. Understand? Similarly, for the cosine transform, what about the cosine transform? Fourier cosine transform of f of x is equal to square root of 2 by pi integral x is equal to 0 to x is equal to infinity f of x cos sx into dx. So here x is the input variable. This is called the kernel of the Fourier cosine transform. So the output is fc of s. This is the third formula, Fourier cosine transform. What about the inversion formula? Because I didn't introduce the inversion formula here. So what is the inversion formula for Fourier sine transform as well as for the cosine transform? Yeah, the same thing, the reverse. What is the inversion formula? 2 by pi integral s is equal to 0 to s is equal to infinity. Now the input is f s of s sine transform only. So sine sx ds instead, because the input is s. So the outcome is f of x. The reverse. The cosine transform, again the same idea. 2 by pi s is equal to 0 to s is equal to infinity. This time the input is fc of s cos sx into ds. So this is the input. Now the outcome is f of x. So this is the f of x. So this is the Fourier cosine transform pair. This is the Fourier sine transform pair. So this is called the third one, Fourier cosine transform pair. Fourier cosine transform pair. Got it? And interesting, isn't it? So full range means complex Fourier transform. When we divide by using the definite integral property with respect to the even functions, we get sine and cosine transform. It's called half range series. As you know that the Fourier series we have used half range sine series, cosine series. Thus here it's called half range. Half range is on the positive range, 0 to infinity, 0 to infinity, due to the even function concept. Okay, thank you so much for watching our YouTube channel. Please kindly support us. ADC Max.